A mixture of light consisting of wavelength 590 nanometer and an unknown wavelength illuminates Young's double slit and gives rise to two overlapping interference pattern on the screen. Right. The central maximum of both the lights coincide, and there were two wavelengths basically different, and they are illuminating a screen basically. And further, it is observed that the third bright fringe of the known light coincides with the fourth bright fringe of the unknown light. From this data, what is the wavelength of the unknown light? Right. Now, what is happening is basically this is the screen, and let us suppose this is the point of central maximum. So, at a distance y, right, at the same distance, these two lambda 1, which is known, basically is forming third maxima, and lambda 2 is forming the fourth maxima. Right. So y is same for the both. That means, and we know that y is given by formula n lambda capital D by small d. Right. Now y is same. So that means this will be equal to what? 3 into lambda which is known. Third bright fringe of the known light. What is the free wavelength? 590 nanometer into 10 raised to the power minus 9 d by d. And same y will be for the fourth bright fringe. Fourth into lambda, let us suppose, which is unknown, into d by capital T. These two will be equal. So I can write it as 3 into 590 into 10 raised to the power of minus 9. This will be equal to what? 4 into lambda. Right. So this means that lambda will be equal to 3/4 of 590 into 10 raised to the power of minus 9. Right. So this, if I cut, this will be 2, and this will be how much? 2, 9, 5. Right. I can again divide. This will be 1, 4, 7.5. And if I multiply by 3, eventually what I'll get as 442.5. Right. 442.5 nanometer basically. 442.5 nanometer. So that means option C will be correct.